Hey guys, welcome back to my channel. Today we're going to do the AQA Level 2 Further Maths paper for June 2025. We're going to go through all of these questions in detail and see how this paper was, whether the questions were easy or difficult. And through this video, you will be able to know how you performed in your test. So let's start with the first question. First question says the function f is given by f of x equals to 5x plus 3. The range is f of x is less than 23. We have to work out the domain of the function, giving an answer as an inequality. 5x plus 3 is less than 23. Just replace the function with its, equation. Then we solve this inequality. 5x is less than 23 minus 3. 5x is less than 20. X is less than 20 divided by 5, and that's 4. So x is less than 4 is the answer. This question was quite straightforward, like simple inequality and function question. The second part says that the function g is given by g of x equals to x cubed minus 4. The domain is x is greater than -3 but less than 2. Work out the range of the function giving the answer as an inequality. So what we're going to do is we're going to substitute the value of -3 and 2 in this function first. So g of -3 is going to be -3 cubed minus 4. That's -27 minus 4, and that's -31. Then g of 2 equals to 2 cubed minus 4, which is 8 minus 4, 4. So your range is less than 4, but greater than -31. And that is your answer. The next part says as a function h is given by h of x equals to root of 2x plus 1. We need to work out the inverse of this. Again, very simple. Replace h of x with y first. It's going to be y equals to root of 2x plus 1. To get rid of the root, we're going to square both sides. So that's going to be y squared equals to 2x plus 1. Now we take the 1 to the other side. So y squared minus 1 equals to 2x. Then y squared minus 1 divided by 2. So replace x with each inverse x and y with x. So x squared minus 1 over 2 is your inverse. That's your answer. Then in question number 2, we have matrices and they're asked us to find the value of a and b. So when we're multiplying, matrices, we multiply the first row, the column first, and then the second row to the column. So that's going to be 5 times 12 plus 0 times 7, and then 1 times 12 plus 7 times -6. This is equal to 15 times A and B. So that's 60, and that's 12 minus 42 over here. 12 minus 42 is -30. So now if we take 15 common from this, it's going to be 15 bracket 4 over here and -2 over here. So A is 4 and B is -2. That's your answer. Question 3 says the linear sequence starts 2, 5, 8, and 11. Work out the position of the term that is the first to have a greater value than 500. So for that, first you make the nth term. Nth term is going to be 2 plus n minus 1. 2 is your first term. So this is your first term times the common difference, which is 5 minus 2. For the difference, we just subtract any two consecutive terms. So that's 2 plus n minus 1 times 3. We need to find the position of the term that is the first to have a value greater than 500. So 2 plus 3n minus 3 is greater than 500. So that's 3n minus 1 greater than 500, which is 3n greater than 501. So n is greater than 501 over 3, which gives us a value of 167. So n is greater than 167, so that's 168. That is n. It says to work out the position of the term that is the first to have a value greater than 500. So the first number after 167 is going to be 168. That's greater than 167. So that's your answer. Then question 4 says AC is a straight line. A is the point with the coordinates -3 and 2. B is the midpoint of AC. And B is the point with coordinates 12 and 10. We need to work out the coordinates of C. Once again, very straightforward. We just use the midpoint formula over here, which is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we have the midpoint, that's 12 and 10, and we have to find the coordinates of C. So x1 can be -3 plus x2 over 2, and y1 can be 2 plus y2 over 2. Now what you're going to do is you're going to put the x part equal to each other and then the y part equal to each other. So 12 equals to -3 plus x2 over 2. 2 times 12 is 24. 24 plus 3 is x2, and that's 27. That's the x coordinate for C. And for the y coordinate, 10 equals to 2 plus y2 over 2, 20 minus 2, and that's 80. So the x value is 27 and the y value is 80. That's your answer. Question 4 says work out the distance AB. So we're going to use the same coordinates because it's the same question. A was -3 and 2, and B was 12 and 10. So we use the distance formula for this. That's root of y2 minus y1 whole square plus x2 minus x1 whole square. 10 minus 2 squared plus 12 minus -3 squared. 10 minus 2 is 8. 8 squared is 64. 12 minus -3 is 15. 15 squared is going to be 225. 64 plus 225 is 289, and that gives us 17. So 17 is the distance of AB. Question 5 says, here's a sketch of y equals to x squared plus bx plus c. The graph passes through -1, 0, and 5, 0. Work out the values of b and c. So these are our x-intercepts. So x plus 1 times x minus 5 equals to y, basically. So expand the bracket, x squared minus 5x plus x minus 5. Select the ligands, x squared minus 4x minus 5 equals to y. So we can see that b is -4 and c is -5. These are your answers. Question 6 says root of 75 minus root of 27 divided by root of 48. We have to simplify this here. So to simplify this, what we need to do is we need to prime factorize the numbers inside the roots. So 75 can be broken down into 25 times 3, and 25 is 5 times 5. Similarly, 27 can be broken down into 9 times 3, and 9 is 3 times 3. And for 48, that's 6 times 8. 6 is 3 times 2. 8 is 4 times 2, which is again 2 times 2. So if we rewrite these, we have 5 squared times 3 minus 3 squared times 3. I'm going to keep the square and 3 separate because like we're taking a square root. So obviously if we're taking a square root, we can only take the square root of a square number. So if there are any squares, let's keep them separate as squares. Divided by 2 square, again 2 square, and then times 3. Square root of 5 square is 5, so 5 comes outside and 3 remains inside. Square root of 3 square is 3, so 3 comes outside and the other 3 remains inside. And this is basically 4 and root 3. Square root of 1, 2 square is 2, so that 2 comes outside. Same goes for the other one, so then 2 times 2 became 4. Now the numbers inside the surd are exactly the same. So now we can subtract them. Before we couldn't directly subtract them because the numbers were not same. This is why we prime factorized it. This is why we prime factorized these to make the numbers inside the surd same so that we could further add or subtract them. Now 5 root 3 minus 3 root 3 is 2 root 3 over 4 root 3. We can simplify 2 over 4. So that's 1 over 2 and the root 3's also get cancelled out. So this is your answer. Next question says that here's a sketch of y equals to tan x for x is greater than equal to 0 and less than equal to 360. You are given that tan 72 equals to k. Work out the two values of x between 0 and 360 for which tan x equals to negative k. If tan 72 equals to k, that means values of y are positive when tan is equal to 72. Now tan is positive in the first quadrant and in the third quadrant. Tan function has a period of 180. That means the angle is going to repeat itself after every 180 degrees. So now to figure out the values of x between 0 and 360 when tan x is negative k, with 72 we're getting positive k. So for negative k, that means 72 is going to be in the second quadrant and in the last quadrant, because that's where k is negative. So what we'll do is, one value of the angle is going to be 180 minus 72, and that gives us 108. And the other will be 360 minus 72, which is 288. So these are the two angles between 0 and 360 where tan x is negative. Question 8 says work out x to the power of 9 over 2 over x to the power of 1 over 2 whole power 3 as power of x. So first, we can simplify the powers inside the bracket. So whenever we have similar bases, x being the base being divided, we subtract the powers. So 9 over 2 minus 1 over 2 is going to give us x to the power of 8 over 2, which is x to the power of 4. Now we cube this, x to the power 4 whole power 3. Whenever there is a power outside the bracket, inside the bracket, we multiply the powers. So that's x to the power of 12. So this is how you solve this question. For this, you need to remember your rules of indices. Whenever similar bases are being divided, we subtract the powers. If they're being multiplied, we add the powers. And if there's a power inside the bracket and outside the bracket, you multiply those powers. Then question 9 says 3-digit integers are made using 3 different digits. The digits are chosen from 1, 2, 3, 4, 5, 6, 7, 8, 9. How many more odd integers than even integers can be made? So we're making a 3-digit number, 1, 2, 3. For odd number digit, we can have 1, 3, 5, 7, and 9 in the last number. For an even digit, we can have 2, 4, 6, and 8 in the last number. We have to determine how many more odd integers can be made as compared to the even integers. So if we pick the first digit over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits. So we already know that the last digit is going to be an odd number over here. So 1 digit is already out of our list. So that means we're left with 8 digits. So we have the choice of picking from 8 digits for the first number. Now another digit is gone. So now we have a choice of picking from 7 digits. And over here we have an option to pick from 5 numbers. So 8 times 7 times 5 is for odd, which is going to give us 280. Now for even, we already chosen that in the last number, it's going to be an even number. So 1 is already gone from over. So again, we have 8 options over here. 7 over here, but now we have 4 options over here because we have 4 even numbers. So for even, it's going to be 8 times 7 times 4, which is going to give us 224. It says how many more odd integers can be made as compared to the even ones. So we do 280 minus 224. That is going to give us 56. So we can make 56 more odd integers compared to the even ones. Question 10 says PQ is perpendicular to QR. Work out the value of A. So if PQ is perpendicular to QR, that means we can use the gradient of the line QR to figure out the value of A over here. Why? Because when two lines are perpendicular, the product of their gradients equals to -1. Always. Like that's a given condition. So gradient of QR is going to be 12 minus 0 over 3 minus 9, 12 over -6, and that's -2. For gradient of QP, we do -2 times gradient of QP equals to -1. So that's going to give us 1 over 2. Now, 1 over 2 equals to 12 minus A over 3 minus 0. We just put the values in the gradient formula. So 3 equals to 24 minus 2A. I cross multiplied. 3 minus 0 is 3 times 1, 3. 2 times 12 is 24 and 2 times A is -2A. So 2A equals to 24 minus 3 and that's 21. And A is going to be 21 divided by 2, which is 10.5. That is your answer. Question 11 says solve x cubed plus 10x squared plus 8x equals 0. Where appropriate, give your answer in surd form. Simplify your answers where possible. So first, we need to see if there is anything common between all of the terms. As you can see, every term is being multiplied by x. So we take x common, and that leaves us with x squared plus 10x plus 8 inside the bracket. So one value of x is 0, and then we put this bracket also equal to 0. Now we can see that this is a quadratic equation, so you factorize this quadratic equation to find the other values of x. So you can use the quadratic formula, middle term breakage, or even completing square, whichever method is easier for you to understand. Since the question said that where appropriate, you give your answer in surd form. So I'm going to use the quadratic formula over here because middle term breakage won't give us the surd answer. So x equals to -10 plus minus root of 10 squared minus 4 times 1 times 8 over 2 times 1. That's -10 plus minus 100 minus 32 over 2. 100 minus 32 is 68. Now we prime factorize 68. 68 is 34 times 2. And 34 is 17 times 2. So we can rewrite 68 as 2 squared times 17 over 2. So that's going to be -10 plus minus 2 root 17 over 2. -10 divided by 2 is -5, plus minus 2 divided by 2 is 1, so root 17. So your other values of x are -5 plus root 17 and -5 minus root 17 along with x equals to 0. So that is your answer. Question 12 says A, B, and C are points on a circle with center O. Prove that y equals to 180 minus 5x. So first thing you need to know is that this is not a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral when all of the vertices of the quadrilateral inside the circle are touching the circumference. Over here, only 3 are touching the circumference, not all. This one is in the center. So we cannot say that opposite angles add up to 180. That is out of our options. Next thing, what we can do is that we can find this angle. This angle is going to be 360 minus 4x. Now, based on one of our circle theorems, angle at the center is twice the angle at the circumference. This is the angle at the center, and this is the corresponding angle at the circumference, which means 360 minus 4x is basically twice the angle of y plus 3x. So that means 360 minus 4x equals to 2y plus 6x. 360 minus 4x minus 6x equals to 2y. 360 minus 10x is 2y. Divide both sides by 2. So that's going to be 180 minus 5x equals to y. And that's exactly what the question was asking us to prove. So for this question, you need to remember your circle theorems. We need to remember that angle at the center is twice the angle at the circumference. And that is applicable in this direction as well, when you have this angle and this angle. This angle was found by subtracting 4x from 360. Normally, what you know is that we have an angle like this over here, something over here, and then something over here. That was the other option. You could have done that. You could have said that 4x divided by 2 is 2x. So you would get this angle. And then 2x plus y plus 3x equals to 180, which is the cyclic quadrilateral one. But then you're making your own cyclic quadrilateral over here. It's not already given. So you can also do that, or you can just use the shape given in the question, and you can also use the same rule over here, which is angle at the center is twice the angle at the circumference. Next question says that here are 4 sketch graphs. Circle the letter of the sketch graph that represents y equals to 5 to the power of x. So y equals to 5 to the power of x is going to be above the x-axis. So these two are out of our options. Now, it says y equals to 5 to the power of x. So that's going to be c. The reason why it's c is because it's an increasing function. In a, it's a decreasing function. We're going towards the x-axis over here. Whereas over here, we're going away from the x-axis. So it's c. Question 14 says simplify fully 2x squared minus 4x minus 6 over x squared minus 3x divided by 4x plus 4 over 7x squared. So that's the algebraic fractions. First, you need to know how to simplify your algebraic fractions. If there's a quadratic equation, you will factorize it. You can take highest common factor if possible, or you use the splitting the middle term or the quadratic formula to factorize it, depending on what the equation is. So we have a quadratic equation over here in the first fraction in the numerator. We first see if there's anything common between the numerators and denominators. So for the first fraction, we have 2 common in the numerator. So 2 bracket x squared minus 2x minus 3. X common in the denominator, x bracket x minus 3 divided by 4 common, x plus 1 over 7x squared. Whenever we have fractions being divided, we take the reciprocal of the second fraction and change the division into multiplication. So it's going to be 2 times x squared minus 2x minus 3 over x times x minus 3 times then 7x squared over 4 times x plus 1. This x gets cancelled out and this x has power of 1 now. This 2 gets cancelled out and this becomes a 2. So now we have 7x bracket x squared minus 2x minus 3 over 2 bracket x plus 1 times x minus 3. Next, what we will do is we will factorize this quadratic equation over here. I'm going to use splitting the middle term. You can use any method that suits you. multiply the coefficient of x squared with the constants, that's 3. Factors of 3 are 3 and 1. So we can use 3 and 1 to replace 2x. So it becomes x squared minus 3x plus x minus 3. What we did was we used the factors to replace the middle term. So 2x became negative 3x plus x over 2 times x plus 1 times x minus 3. So now 7x bracket. Between x squared and 3x, we have x common. So x minus 3 plus 1 times x minus 3. The main reason behind splitting the middle term was to add another term so that we can factor by grouping. As you can see, when we split the 2x into negative 3x plus x, now we split the equation into two groups. The first two terms make one group and the last two terms make another group. Then we factorize those groups separately. So between x squared and 3x, we have x common, and between x and 3, we have 1 common. So then we write the denominator as it is. After that, we're going to take the x minus 3 common, so 7x bracket x minus 3, and then x plus 1 comes in the other bracket, over 2 times x plus 1 times x minus 3. As you can see, the x minus 3 is getting cancelled out, and so is the x plus 1 because they're getting multiplied to each other. So we're left with 7x over 2 as the simplified fraction for this question. Question 15 says x minus 3 times x plus 1 times x plus 3 is identical to x cubed plus qx squared plus rx plus 24. We need to work out the values of p, q, and r. So for this, we will expand the brackets on the left-hand side first. So x minus 3 times x plus 4 times x plus p. That's going to be x squared. I'm expanding the first two brackets first. Plus 4x minus 3x minus 12 times x plus p, x squared plus x minus 12. Now we expand these two brackets. X squared times x is x cubed. X squared times p is x squared p. X times x is x squared. X times p is xp. Negative 12 times x is negative 12x, and then we have negative 12p. We're going to put similar terms equal to each other. So on the right-hand side, x cubed is the same as x cubed, so we don't do anything to that. We have x squared p, and then we have x squared q. Over here, we have x squared p plus x squared, we have x squared q. So x squared p plus x squared equals to x squared q. The x squares get cancelled out, so it's p plus 1 equals to q. That is your first equation. Then, for the p, we have xp over here with negative 12p, and over here, for x, we have xp and negative 12x, and over here, we have rx. So xp minus 12x equals to rx, which means p minus 12 equals to r. That is your second equation. And negative 12p is equal to 24, which means p is negative 2. So we have the p value. We can find the q value. Q is negative 2 plus 1, that's negative 1. And r is going to be negative 2 minus 12, which is negative 14. So these are your answers. Very simple. When you have an identity, you first expand the brackets if there are any, and then you put the same terms equal to each other. So if there's anything with x squared, you combine it on one side, and then put equal to the x squared on the other side. Same for x, and then at the end, to put the constants equal to each other to find the value of the missing variables. Question 16 says, work out the length of AC. Give your answer in the form of a root 2, where a is an integer. So we have two angles and one length. We can either use cosine rule or sine rule in this because it's a non-right angle triangle. So if you look at the given information, we have one complete set of angle and length, which means we can use sine rule over here. Cosine rule cannot be used because for the cosine rule, we need two lengths and the angle between them. We don't have that over here. Hence, we'll stick to sine rule. So, sine rule says that 10 over sine 44 is going to be the same as AC over sine of 30. This is AC. So, the angle opposite to AC is 30. Now, for this, we need the value of sine 45 and sine 30. Since it's a non-calculator paper, so you need to remember your values of trig ratios. So for sine 45, if we draw a right angle triangle, 45, 45, 90. So this is root 2, this is 1, and this is 1. This is one of it. This is one of the special triangles. You need to know this like by heart. So if this is 45 and this is also 45, sine 45 is opposite over hypotenuse. So opposite is 1, hypotenuse is root 2. So 10 over 1 over root 2. Then for sine 30, we draw the other special triangle, which is the 30, 60, 91. 30, 60, 90. So if 30 is 1, 90 is 2, 60 is root 3. So based on this, sine 30 is going to be opposite 1, hypotenuse 2, so 1 over 2. So this is sine 30. So now it's going to be 10 times 1 over 2 equals to AC times 1 over root 2. 10 divided by 2 is 5. 5 times root 2 is 5 root 2, and that is your value of AC. Once again, for these type of questions, you need to know your exact value of trig ratios. You need to know your special triangles. And without that, you won't be able to solve these because this is a non-calculator paper. Also, you need to know the conditions for using sine rule and cosine rule or Pythagoras or any of the other trig ratios. You need to be very familiar with those. If you're someone who doesn't know how to find the exact value of trig ratios, I'm attaching a link to a short above. You can use that. I've shown a trick in that you can memorize the trick to learn how to find the exact value of trig ratios. Then question 17 says the expansions of 4a plus x to the power of 4 and 5 minus 2x to the power of 3 have the same coefficient of x cubed. Work out the value of a. So for this, what you need to do is that you need to rewrite 4a plus x to the power of 4 as 4a plus x squared times 4a plus x squared. Because both the squares being multiplied give us 4a plus x to the power of 4. You know we cannot use binomial expansion over here because it's a non-calculator paper. So you just have to split the brackets down, multiply them, and see what the expansion is going to be at the end. So 4a plus x whole square is going to be 16a squared plus 8ax plus x squared. So this is getting multiplied to itself. In the question that is saying that the coefficient of x cubed is the same for both expansions. So let's just focus on the x cubed terms. So 16a squared doesn't get multiplied to anything. We can multiply 8ax to x squared. That gives a cube. So that's going to be 8ax cubed. And then we can multiply the x squared with 8ax again. So that's also going to give us 8ax cubed. So add them up, so that's 16ax cubed. This is the quotient of x cubed from this expansion. Then for 5 minus 2x whole cube, that's 5 minus 2x squared times 5 minus 2x. That's 25 minus 20x plus 4x squared times 5 minus 2x. Now, x cubed will be 4x squared times negative 2x, which is negative 8x cubed. Other than that, we're not getting any cubes. We put 16ax cubed equal to negative 8x cubed. The cubes get cancelled out, so A equals to 8 over 16, which is 1 over 2. And there's a negative over here as well. So negative 1 over 2 is our value of A. So once again, you expand the brackets first, split them into smaller brackets, and then expand them separately. It's clearly saying that the expansion of both the brackets have the same quotient of x cubed. So you don't need to do the entire expansion over here for once we have done the separate expansions. You just highlight the terms which will give you x cubed, multiply those and write them, and then put them equal to each other. And that gives you the value of A, which is negative 1 over 2. Next question says that a 60 centimeter piece of wire is bent to form 3 sides of a rectangle. It is then attached to a fixed rod as shown in the diagram. The area of the rectangle is 8 centimeters square. Show that A equals to x times 60 minus 2x. So they have given us the length of the wire. So 60 is equal to x plus y. So 60 is equal to 2x plus y. And if you make y the subject, 60 minus 2x equals to y. We have to show that the area is x times 60 minus 2x. So area is going to be x times y. And y is 60 minus 2x. So that's your answer. The next part says that work out the maximum value of A as x varies. So whenever it says maximum value of any equation, that means we're talking about differentiation. So A was x times 60 minus 2x. You can expand the bracket, 60x minus 2x squared. And now we differentiate A with respect to x. So whenever we're differentiating an equation, you bring the power down of the variable and then subtract 1 from the power. So when you bring the power down, it gets multiplied with the term. So x has a power of 1 over here. So it's going to be 60 times x to the power of 1 minus 1. Bring the 2 down. So 2 times 2x to the power of 2 minus 1. So that's 60 minus 4x. Now it says maximum value, which means the derivative would equal to 0. Because at the maximum and minimum value, your derivative is always 0. So put dA over dx equal to 0. 0 equals to 60 minus 4x. 4x equals to 60 and x equals to 15. Then for the maximum value, you will put this value of x back into the area equation, and that gives you the maximum value of the area, because this is just the maximum value of x, not the area. So 15 times 60 minus 2 times 15. 15 times 60 minus 30. 15 times 30, and that equals to 450. 450 is the maximum value of the area as x varies. Question 19 says x minus 1 is the factor of 3x cubed plus 2x squared minus 3x minus 2. Factorize fully 3x cubed plus 2x squared minus 3x minus 2. So if it's a factor, that means we can just divide it by x minus 1 and then find the remaining factors. So x minus 1 and over here 3x cubed plus 2x squared minus 3x minus 2. So we're going to do long division to factorize this equation. First, we start with multiplying 3x squared with x. Why? Because 3x squared times x is going to give us 3x cubed. And when we subtract the 2, we get a 0. Then 3x squared times 1 is going to be negative 3x squared. Subtract the 2. That's going to give us 5x squared. 2x squared minus negative 3x squared is 5x squared. Then negative 3x and negative 2 come down as it is. Now to get rid of the 5x squared, we multiply 5x with x. So 5x squared. Subtract the 2, that's 0. 5x times -1 is -5x. Again, subtract the 2. So negative 3x minus negative 5x is 2x. Minus 2 comes down as it is. Then we times x by 2. So 2 times x is 2x minus 0. That's -2. If we subtract -2 from -2, that is going to give us 0 again. So 3x squared plus 5x plus 2. What we get is 3x squared plus 5x plus 2. It says fully factorized. So let's see if we can factorize this quadratic equation. I'm going to use splitting the middle term. 2 times 3 is 6. Factors of 6 are 6 and 1 and 3 and 2. We can use 3 and 2. 3x squared plus 3x plus 2x plus 2. Between 3x squared and 3x, we have 3x common. So x plus 1. Between 2x and 2, we have 2 common. X plus 1. Take x plus 1 common. So we're left with 3x plus 2 over here. So your factors are x minus 1 times x plus 1 and then times 3x plus 2. This is your fully factorized expression. 19b says we have a function x minus 2 times 5x plus 4 times 3x plus 2. C is a positive integer. The value of function f of c can be written as the product of two prime factors. Reduce the value of f of c. So since it says that f of c can be written as the product of two prime factors, which means one of these brackets will equal to 1, because prime number is only divisible by itself and 1. So if we put x minus 2 equal to 1, that gives us x equals to 3. If we substitute 3 into the function f of 3, it's going to be 3 minus 2 times 5 times 3 plus 4 times 3 times 3 plus 2. That's 1 times 5 times 3 is 15 plus 4 is 19. 3 times 3 is 9 plus 2, 11. So 19 times 11 is going to be 209. That is your answer. Question 20 says y equals to x cubed over 3 minus 5x squared plus 28x plus 11. Show that y is an increasing function for all values of x. So we differentiate this. Dy over dx equals to, bring the power down, 3 times x, 3 minus 1 in the power over 3, minus 2 times 5 times x to the power of 2 minus 1, plus 28 times x to the power of 1 minus 1, plus 0. 11 becomes a 0 because every constant that is differentiated becomes a 0 because there's no x with the constant, so its derivative is going to be 0. So that's going to be x squared minus 10x plus 28. To show that y is an increasing function, we convert the dy by dx into completing square form. To convert the completing square form, we need to remember that the square that we're trying to complete is this. And why? Because a square looks like a minus b whole square, which is a square minus 2ab plus b square. We have our a square, we have our minus 2ab, but we don't have our b square. So to complete this square, we need to find our b square value. So we can put the negative 10x equal to negative 2xb, and that gives 5 as our b value. So it's going to be x squared minus 10x plus 5 squared, but minus 5 squared as well, because 5 squared is a new term that we're adding in the equation. So if we're adding something new, we're supposed to subtract it as well. It's very similar to when you're solving fractions and when you're making the denominators equal. If you're multiplying the denominator by something, you're multiplying the numerator by the same thing as well. So we're using the same concept over here. And now this is the complete square. So it's going to be x minus 5 in the bracket, whole square. And this minus 5 square comes outside. So minus 25 plus 28, which is x minus 5 squared plus 3. Now, since we're adding 3, that means it's an increasing function. If we were subtracting 3, it would be a decreasing function. So y is an increasing function. Also, if we draw this, x is 5, y is 3. So it's like this. It's increasing. It's a minimum function. If it was a maximum function, it would be upside down. This is for decreasing function. So you need to know how to identify what shows an increasing function, what shows a decreasing function, how like your coordinates give that. If there was a negative sign over here outside the bracket, then it would be a decreasing function. Since it's positive, that's why it's increasing function. So that's your answer. Next says that show that 20 sine square x over 3 plus cos square x minus 3 sine square x can be simplified to k times tan square x where k is an integer. So 20 sine square x over 3 plus cos square x minus 3. I'm going to rewrite the sine square x as cos square x because tan is sine over cos. So I want cos in the denominator and sine in the numerator. So sine square x becomes 1 minus cos square x. So that's 20 sine square x over 3 plus cos square x minus 3 plus 3 cos square x. That's going to be 20 sine square x over 3 minus 3 is 0. And cos square x plus 3 cos square x is 4 cos square x. Sine square x over cos square x is tan square x. And 20 divided by 4 is 5. So 5 tan square x is your answer. So a key rule for this is that you need to remember your trig identity. Cos square x plus sine square x equals to 1. And tan square x equals to sine square x over cos square x. Next question says that a circle has center 2, 3 and radius 5. A straight line passes through 3, 7 and has a gradient of 2. Work out the coordinates of the 2 points where the circle and the straight line intersect. So we have the center of the circle and we have the radius. So we can create an equation for the circle, which is going to be x minus 2 squared plus y minus 3 squared equals to 5 squared. So that's x minus 2 squared plus y minus 3 squared equals to 25. This is your equation of the circle. Now for the line, it says that it passes through 3, 7 has a gradient of 2. We can create the equation of the line as well. Y minus 7 equals to 2 times x minus 3. I'm using point slope form because you have a point and a slope. So y minus 7 equals to 2x minus 6. Y equals to 2x minus 6 plus 7. And that's y equals to 2x plus 1. That is your equation of the line. Work out the coordinates of the 2 points when the circle and straight line intersect. So we can replace y with 2x plus 1 in the circle equation. So x minus 2 squared plus 2x plus 1 minus 3 squared equals to 25. X minus 2 squared would become x squared minus 4x plus 4 plus 2x minus 2 squared equals to 25. Expand the other bracket as well. So that's going to give us 4x squared minus 8x plus 4 equals to 25. Collect the like terms. X squared plus 4x is 5x squared. Minus 4x minus 8x is negative 12x. 4 plus 4 is 8 equals to 25. You can bring the 25 to the other side. So 5x squared minus 12x plus 8 minus 25 equals to 0. 5x squared minus 12x minus 17 equals to 0. Factorize quadratic equation. So we can do 5 times 17, which is 85. And we know that 17 minus 5 will give us 12. So we can just replace 12 with negative 17x plus 5x minus 17 equals to 0. There is x common between the first two terms. So x bracket 5x minus 17 and 1 common between the last two terms. So 5x minus 17. So we have 5x minus 17 and x plus 1. So one value of x is 17 over 5 and the other is negative 1. Now we have to find the corresponding y values as well. So we put them into y equals 2x plus 1. Y equals to 2 times 17 over 5 plus 1 is going to give us 39 over 5. And y equals to 2 times negative 1 plus 1 is going to give us negative 1. So negative 1 and 39 over 5. Next question says the diagram shows a trapezium. All lengths are in centimeters. The area of the trapezium is less than 22 centimeters square. Work out the greatest possible range of values of x. Giving your answer in the form of x is greater than m but less than n, where m and n are both positive numbers. So the area of trapezium is less than 22. So area of trapezium is 1 over 2 times the sum of parallel sides. These two are your parallel sides, x plus 5 plus 3x minus 8 times the height. This is your height. And this is less than 22. This is our equation. So now let's solve this. The 2 gets cancelled out. X plus 3x is 4x. 5 minus 8 is negative 3 times x is less than 22. That's 4x squared minus 3x. Bring the 22 to the other side. So that's 4x squared minus 3x minus 22 less than 0. As you can see, we got a lot of quadratic equations in this paper, a lot of factorizing. So this is going to be good practice for you if you're preparing for May, June 2026 AQA Level 2 further maths, because a lot of factorization happening in this paper. So factorize this. 4 times 22 is going to give us 88. 88 is 11 times 8 and 11 minus 8 is 3. So we can replace 3x with negative 11x plus 8x and everything else comes as it is. So between the first two terms, we have x common. 4x minus 11 comes here. And in the last two terms, we have 2 common. So 4x minus 11 comes over here. So 4x minus 11 times x plus 2 is less than 0. Now, you need to know that when we have a quadratic inequality, we had negative 2 and 11/4 as our intercepts. So if it's less than 0, we look at the behavior of the x values underneath the x-axis. So this is our focus region. So over here, x equals to negative 2 is increasing and x equals to 11/4 is decreasing, which means x is less than 11/4, but it's greater than negative 2. However, our x value cannot be negative. Why? Because it's a measurement. If we do negative 1 times 2, that's going to give us negative 2. Negative 2 cannot be the measurement, which means we need to only focus on the positive values. Since the lengths of the trapezium need to be positive, what we will do is we will put one of the lengths greater than 0, which will give us 3x greater than 8 and x would be greater than 8 over 3. The reason why I did not choose x plus 5 greater than 0 because it would again give us a negative value. And 2x greater than 0 would also give us 0. So this is the best option, x greater than 8 over 3, because that covers all of the values that will come in the range. So now we replace this by 8 over 3, and that is your value of m and n. And with that, we're done with the AQA Level 2 Further Maths Paper 1. This was the non-calculator paper. If you have any questions or confusions regarding any of these, please leave a comment below and I'll try to help you out. And if you understood everything and you like this video, please like and subscribe and share this with your friends.